All right. We're going to talk about the natural log today, lesson 8.7. It's just a special logarithm, that's all it is. Now, for the next few slides, I'm not going to make you guys write stuff down. This is just for your information about what it is we're doing and why we're doing it. So, but please do listen. So first of all, we're talking about this thing called the natural base, and it's called e. All right? What is e? It's an irrational number. That means it's a decimal number that goes on forever, no pattern. You can't write it as a fraction. It's just irrational. And it just seems to pop up in the real-world application of mathematics all the time. It's one of those numbers that are just kind of written into our universe. It's just there. Like pi. Pi is just another funny number. Nobody knows why it's in our math so often, but it's there. It's a naturally occurring number which is particularly related to logarithms. And one way this number seems to just pop out is with the formula we learned last time, the compound interest formula. I'm going to show you guys how that is. Okay? Now I'm going to do the first one for you, and then I'm going to let you guys do the other ones. Okay? Now, suppose you invest $1 at 100% interest. All right. Well, here we go. My compound interest formula is A equals P times 1 plus R over N to the N times T, right? All right. Well, if I'm investing $1, what is my P? It's 1. And what's the rate? 100%, which in decimal world is 1 over N times T. And in terms of the T, we're just going to ignore that for right now, and I'll tell you why later. But for now, we're just going to ignore the time because it's going to be kind of an interesting thing that happens here. Now, the N, for this one, is annually. That means N equals 1. So I'm going to plug in 1 for my N here and here. And so I'm just going to do my calculations. 1 plus 1 over 1 is 2. 2 to the first power is 2. Times 1 is 2. So my result is 2. All right? I'm going to get you started in the second one, and I'll let you guys calculate it. So once again, we're at $1. My rate is still 100%. The only thing that's changing is the N. Since it's semi-annual, it's going to be 2. Okay? I'm going to let you guys continue on this table chart and fill it in. I'm going to give you about 5 minutes, and then I'm going to call on you. We're going to talk about our results. Go for it. So here's the point of our doing this. Besides giving you guys more practice with your calculators and knowing how to use the compound interest formula, notice it starts at 2. Then it goes up to 2.25 for 2 compounds. For 4 compounds, 2.44-ish. For 12 compounds, 2.6-ish. And these numbers just keep on going. Now let's look at the last number there, 2.71. Probably doesn't look familiar because we've seen it a few minutes ago, but look. 2.7182. The bigger N gets, the closer you get to that exact number. In fact, if you let N go on to infinity, it would equal exactly that. And that's one way that E just kind of seems to pop out in our math. Okay? So that's what E is. This is some calculus notation. So if you take this formula we were using, right, and you let N go into infinity, it comes out to equal exactly that decimal I gave you for E, which is 2.718, blah, blah, blah. Okay? So that's one way that E kind of pops out. E pops out in a few different things. I know something, it comes out in something else called a Taylor series, which is a calculus topic. But it's in a few different places. So that's what E is. It's just a special number that kind of comes out of the math in a variety of ways. All right, now let's move along. We'll talk a little bit more about it. So as you can infer, exponential equations like e to the x power equals y are very useful equations in applications. And therefore, if we change it to log form, left, right, middle, right, we get a very useful logarithm. So it's so useful, in fact, that they even give it its own name. It's called the natural logarithm. And instead of writing it log base e of y equals x, they get rid of the log e part here, and they just put ln of x. And it means the same thing. So it's just a special log with base e. That's all it is. But it's so special because it's used in a lot of different real-life applications. So let's move along. We're going to work with natural logs today, and here's the good news. If it helps, you just need to rewrite ln as log base e. After that, all the problems we're doing today are just review, because you do the logs, natural logs, same way you do regular logs. It's just another log with a base e. That's all it is. So we're just going to practice. I figure this is a good time to talk about this because our test is next time. So we get to review a lot of the stuff that we've already learned about logs while also using the natural log. So if you guys want to write down these steps, I'll leave them up here for a moment for you.